back to our channel. So today we will learn how to set up Prometheus and Alert Manager in Kubernetes with custom alerts. Prometheus combined with Alert Manager offers a solution for tracking the health and performance of the application. So today we will see a step-by-step process of setting up Prometheus and Alert Manager in Kubernetes, including the configuration of custom alerts. So first, let's see the prerequisites. You should have an AWS account with Ubuntu 24.04 EC2 instance up and running. Then you should have Minikube, kubectl, and Helm installed, and also basic knowledge of Kubernetes. So let's move on with the practical. Our first step is set up Ubuntu EC2 instance. So first, let's update the package list using sudo apt update command. After updating the packaging list, let's install the essential tools like curl, wget, apt transport https. So let's copy this command and paste it. After this, let's install Docker. Now our Docker is also installed. Next, we will add the current user to the Docker group, allowing the user to run Docker commands without sudo. Next, adjust the permission for the Docker socket. This will enable the easier communication with the Docker daemon. Next, checks if system supports visualization. Sorry, virtualization. After this, let's install KVM and related tools. Now our tools are also installed. Next, add the user to the virtualization groups. After this, we will reload the group. Now our next step is installing Minikube and kubectl. So first, let's download the latest Minikube binary. Then install it to user local bin Minikube, which will make it available system-wide. Then we will use Minikube version command to confirm the installation. Here, as you can see, our Minikube is installed successfully. Next, download the latest version of kubectl. Then make the kubectl binary executable. Then to user local bin directory. To check if it's installed or not, we will check its version. As you can see, our kubectl is also installed. Now our next step is start the Minikube. So let's start the Minikube with Docker as the driver. So just wait a minute. Now let's check the status of Minikube. Let's run the Minikube status command. For that, so as you can see, our Minikube is run configured. Now our next step is install the Helm. So let's download the Helm, which is a package manager for Kubernetes. We will change its permission also. Next, let's install the Helm. check its version to confirm the installation. So our Helm is also installed successfully. Then next we will add the Prometheus installed repository using Helm repo add command. So as you can see, our Prometheus repository added. Next, we will update the Helm repositories to fetch the latest charts. Updated. So our next step is configuring Prometheus Alert Manager and Grafana. So for that, we will first create a custom values.yaml file to configure the services as a notebook in it. This code is our file. Here we are writing the Prometheus Grafana Alert Manager and the service type as notebook. Let's save the file. Then we will deploy the Prometheus Alert Manager and Grafana stack. So let's copy this command and paste it. Now this command will deploy the Prometheus Alert Manager and Grafana to the cluster with the services exposed as notebook so that we can access them from our web browser. As you can see, our Prometheus stack is deployed successfully. Now our next step is accessing the Prometheus Alert Manager and Grafana. So first we will list the services to get the notebook details. So let's run kubectl get services command. So here you can see our alert manager, which whose service type is notebook, then also Grafana and Prometheus. So first, let's forward the Prometheus service to port 9090 so that we can access it from our web browser. Let's run this command. Our pod is still in pending state. That's why the error is occurred. So just wait a minute until pod is start. So first, let's see pod is running or not. You get pods. Let's run this command. So as you can see, all our pods are now running. Our Prometheus service is forwarded to port 9090. Now let's access the user interface of Prometheus on web browser. So for that, we will copy the public IP address of our EC2 instance. Now type the URL http:// paste your public IP address colon, which is port number for Prometheus service. Okay, you can see the Prometheus user interface. Now to access the Alert Manager alerts, click on Alerts here to see them. So here you can see the alerts. You can see alerts which are in firing state, pending state, and which are inactive. Now let's open another tab. Here this is. Okay. Now next we will forward the Grafana service port. So first we will forward the Alert Manager. Let's copy them. Now let's access the Alert Manager. So again, let's copy the public IP address of our EC2 instance. Then in URL, type http:// paste the public IP address and 9093 port for Alert Manager. So here you can see the Alert Manager user interface. You can see not grouped alerts and also the one within the namespace cube system. Now let's access the Grafana user interface also. So let's forward its port to open another duplicate tab. Our command and run it. So let's access it also. For Grafana is 3000. So here you can see the user interface for Grafana. Once you entered the username and password, you can log in into it. Now our next step is configuring the custom alert rules. So now we have seen the default alerts configured in Prometheus and Alert Manager so far. So let's also try to add the custom alert rules in it to monitor our Kubernetes cluster. So first we will open another tab and create and define the alert rules in a custom alert rules.yaml file. So let's copy this command. Another tab. Let's open it. Our command. Now inside this file, we will add this code. So let's copy it and paste it. So this is a Prometheus rule file which defines a set of custom alerting rules for monitoring the Kubernetes resources, and it uses the PromQL expressions to specify the conditions under which the alert should fire. So first is our metadata section here. Sorry, here this contains the data for the rule, which includes labels, name. These are the tags to organize or identify the rule. For example, like Cube Prometheus tag, and name is Cube pod not ready, which is a unique identifier for this Prometheus rule. Then there is next is spec section. Here spec defines the structure of the alerting rules. In the groups, there is name, which is my pod demo rules. And rules, there are individual alerted rules are written here. You can see there are many rules written. Here each alert is structured with a name, PromQL expression, as you can see. This is our PromQL expression, and alert duration written in for its severity, and annotation for detailed description. First we have written the Kubernetes pod not healthy alert. Then this is its PromQL expression, which counts the pods in this phases grouped by namespace and pod, and fires if the count is greater than 0. Its duration, where the condition persists for 1 minute. Sorry, this is the one. And severity is critical. And annotation provides the details about the unhealthy pod. Then our second rule is Kubernetes daemon set rollout stuck. This fires if the daemon set rollout is stuck less than 100% ready pods or unscheduled pods. It checks if the number of ready pods is less than the desired number, and fires if all pods are scheduled or ready, and duration is 10 minutes. Its severity is set to warning, and here its annotation is also written where summary and description. In summary, Kubernetes daemon set rollout stuff. Then our next alert written here is container high CPU utilization. which fires when CPU utilizes exceed 80% for a container. This is the Prometheus expression. This calculates the CPU uses as a percentage and compares the uses against 80%, and its duration is persists for 2 minutes. Its severity is warning. Here you can see its annotation also. Container high CPU utilization. Then our next alert is container high memory uses. It fires when the memory uses exceeds 80% for a container. And and it tracks memory uses relative to the container's limit and fires when uses exceeds 80%. Its duration is 2 minutes. Severity warning. Next alert is Kubernetes container killer. This alert detects when a container is killed due to out of memory. It tracks restart due to out of memory events. Its severity is set to warning. Then our next alert is Kubernetes pod crash looping. It detects when a pod is crash looping. It's repeated restarts, and it tracks the number of restarts over 1 minute and fires if restarts exceed 3 within the interval. Its duration is 2 minutes. Severity warning. So let's save this file. Now let's apply the custom alert rules to the Kubernetes cluster. So let's apply them using this command. Just copy and paste it. So our pod is created. Next, let's visit the Prometheus user interface to see the custom alert rules. So here, let's refresh the page. So here, as you can see, the alerts which we have created are added here, which is Kubernetes pod not healthy, then diamond set rollout stuck, also container high CPU utilization, memory. The alerts we have created are added here successfully. Now our next step is deploy test application. So to check our custom alert routes are working or not, we will create an application with wrong image tag. So let's deploy the Nginx pod to test monitoring and alerting. So let's copy this command and paste it. So here the correct tag is latest, but we have written 3 instead of T here in latest. So as you can see, our Nginx pod is created. Now let's check the status of the pod. Copy this command, paste it. Sorry. Here, the pod is not ready and showing an error, image pull back off. Now this will trigger the alert since we have created custom alert rules. So now go back to the Prometheus and Alert Manager. Let's refresh the page again. So here you can see Kubernetes pod not healthy alert is fired. As you can see, the alert related to the pod failure is appeared here. You can see the alert name, the namespace pod, which is Nginx pod, which we have just created, and its severity, which is critical, and it's also showing the description summary. Just go to Alert Manager and refresh it also. So here you can see the namespace default. So here our alert is also visible here also. Kubernetes pod not healthy and pod name, which is Nginx pod. And you can see its severity, which is critical. So today we have seen how to set up a Prometheus and Alert Manager in Kubernetes with custom alerts. And with Prometheus and Alert Manager deployed, you can have a system for monitoring Kubernetes cluster and application. And the custom alerts enable the proactive responses to the issues, which enhances the reliability and performance. And by integrating the Grafana, here you can see the Grafana user interface. So by integrating it, you can visualize the metrics and alerts also, and you can expand this whole setup by adding more custom alert rules and dashboards to meet your operational needs. So that's all for today, guys. Thank you.